Hello, welcome to the presentation of my algorithm homework. In my homework, I totally solved 4 problems. One of them is basic level, 2 of them is medium level, and one of them is hard level. One of the medium level questions was partially solved. So, firstly, I asked for a basic question from ChatGPT, and it gave me an example question. So in this question, I was asked to find the maximum element in an array of integers with divide and conquer approach. For example, there's an input array here and the output should be 12, which is the greatest element in the array. So I asked for a guidance because I couldn't understand what does it mean. So it explained me the things I should do, base case, dividing the array into 2 subarrays, concurring them, which is doing some operations on those subarrays and combining them in the final stage and find the result. So after some work, I found out a function which is called divide and conquer. It takes an array as a parameter. It first calculates the size of the array and stores that value in the length variable. And if the length equals to 1, it returns the element and first index. Then it calculates the mid value, which is needed to use the divide and conquer approach. So in here, it calls the function recursively and divides the array into 2 halves. One of them starts from the index 0 to the mid, another one of them starts from the mid value to the end of the array. And it returns the max value between these 2. So I asked for a debug, so it finds some bugs in my code, but it was some small mistakes. It's actually not a mistake. It only changed the variable names called left list and right list here and changed them to the left max and right max variable names. So it's not actually a problem. So I calculated the time complexity of my solution as O(n) times log n. Why? Because since we are doing a divide and conquer approach, we are dividing the array into 2 halves each time. In each iteration, the input size goes like 2, 4, 8, 16, 32, 64, 128, blah blah blah. So it increases logarithmically in the power of 2. So that's why time complexity is n times log n. So let's move on to the medium level question. So take some time here. Okay, it's here. Okay, so for the medium practice question on divide and conquer, give me a task where I should find the maximum subarray sum in a given array. For example, it gave me an example array here, and it should return 8, which is the maximum subarray sum obtained from the subarray tree for -1, 2. So at the beginning, I barely understand the question, how to find the array in the middle, because, this array was not in the left side or in the right side. It was just passes from the mid value. So I asked for help, and it gave me an explanation on what should I do. So in a base case, divide conquers, it explained me the basics of the divide and conquer approach. And then I wrote a function. In this function, it's called divide conquer sum. It takes an array as a parameter. The size of the array is called length. And if the length is equal to 1, it returns the element at the first index, which is the only element, because there's no need to divide, and it returns the element. So this divider actually the element at the middle, and left sum lists is actually the array start from index 0 to the mid value, and right sum lists is actually the array starts from the middle to the end of the list. So the left total calculates the sum of the elements in the left sum lists, and right total calculates the sum of the elements in the right sum lists. And with this return statement, with this math function, it calculates the max value between these two and returns it. So I asked for a guidance, but at this point I forgot two things. I forgot to, consider the situation where the maximum subarray passes through the mid value. I only checked out for the left and right side of the subarrays. I also forgot to call it recursively. So in the base case and combine step and divide conquer sum recursively on the left and right subarrays, and then combine the results to find the maximum subarray sum. So it explained me what should I do. And then I added a recursive call on the left sum list, and I forgot to add the recursive call on the right sum list. And I also couldn't find how to find the mid array. So I asked for help, because I couldn't understand. It may lie in the cross of the midpoint, as it explained it here. So it explained me what should I do, And at this point, I couldn't find a solution for this problem, finding the mid array, defining the subarray sum that crosses the mid value. So I asked for another medium practice question on divide and conquer, and I wanted to make sure it's different from the question above because it gives the same question sometimes. So in the next question, I was asked to find the second smallest element in the array using a divide and conquer algorithm. For example, here there's a list here, and the output should be 2 because it's the second smallest element, and I should find it with the divide and conquer approach. So for that, I firstly wrote a function called find second smallest. It's actually a merge sort operation. I used a merge sort algorithm in here because it was easier to find, and there were other ways to do it, but we haven't learned it yet, and they were not actually related to the divide and conquer approach. And then they were so complex, so I choose this approach. So we did the usual things here: find the size of the array and check the size and return. So we find the mid value here, and we created two empty lists which is in the size of the mid. For example, if the mid value is 4, then this array size is 4, and the second part has a size of length minus mid. It's the same operation here. And this while loop, the condition is I is smaller than length. The I is, as you can see, is increased by 1 each iteration. So this while loop, puts the elements in the right place in the subarrays. For example, if the I number is smaller than mid, this means that the I number is in the left side of the mid, which is corresponds to the first part, so I put it in the first part. In the else situation, which means that I is smaller than mid, so it corresponds to the second part of the array. So the j is increased by 1 here, and I is increased by 1 here. And I recursively called the functions on this. And I called an ensemble function, but I haven't introduced it yet. So I asked for a guidance here, and it said that I made a good progress here. And here I introduced the assemble function. It takes 3 parameters, left, right, and array. So it actually does the merge operation on the merge sort algorithm. So here we have a left size, which is the size of the left, and it's actually the array's size divided by 2, and right size is the remaining size left from the left size. So we have three integers, 0. So we have a while loop here. So in this while loop, what I'm trying to do was, I was trying to, put the numbers in place. Here, if left L, which is 0 at this point, so, and the right M, which is 0, so it checks the elements in the first index, the 0th index in the left and right arrays, and it puts into the array before the other one, depending on if it's small or big. So here, the left L is smaller than right M. It puts it into the array K, which is the 0th index. So it puts the element at the 0th index of the left array to the array 0th index. So if it's the opposite, it puts the right element at the right index. So it sorts the array, actually. It sorts the array in an ascending order, like a typical merge algorithm do. So here's the sample function. I asked for a guide, if I'm going in the right direction. So it said it's a merge step. Yeah, it was actually a merge step here. And then I wrote the whole code here. I wrote the find second smallest function here, and I wrote the assemble function here. So here I created an array which consists of these elements, and then I called the find second smallest function, and I used it on the array. And then I printed out the first element, the element at the first index. I mean, it's the second element. So why? Because it was already sorted with this function. So the second element should be the second smallest element in the array, since it's sorted in the descending order. So it gave me some basic advice here. And the time complexity was obviously O n times log n, since it's a merge sort operation. So in merge sort operation, we are dividing the array into half. It goes logarithmically in the power of t, same as the other question. So the time complexity is O n times log n. So this is basically what I have done for the medium level. So let's move on to the hard level. Okay. Okay, now let's move on to the top. Okay, so I asked for a hard practice question on divide and conquer. So in this problem, it was actually identical to the previous problem, which I couldn't finish. But I asked for other questions, but it gave me the same question and again, so I wanted to give it a try. So it's the same process, finding the max subarray sum in an array. It gave me some hints at this time, different from the other. So I wrote down a function. It was a function, that is divides the array into two halves, and it uses a sum finder function, which I was aiming to find the maximum element between this left part and right part, and dividing the array into two parts with recalling the function each time. So I asked for a guidance, so give me some explanation. Okay. So I couldn't understand, subarray size. If I divided the array into two halves and the sizes are 4, should the middle array, which crosses the mid value actually, in the size of 4, should it be in the size of 4 or not? I asked for this because I couldn't understand the part. So it said that I don't need to be in the same size. So it says that I didn't need to recursively call the function and continue dividing the subarray in half. It said this to me, just divide the elements, but don't go further. So it said I'm correct, and then I deleted the parts where I recall the function, as I mentioned here, and write some code for SumFinder function. In the SumFinder function, there are two values which is assigned to value 0. So basically it calculates the element sum in the left side array and the right side array. It basically does the calculation for the left and right side, but I couldn't find the solution for calculating the element sum in the mid value, I mean the mid array, which is crosses from the mid value. So I asked for a guidance here. Okay. So I asked for another question, and here I asked another question, if the sizes should be the same or not, And in this here, I rearranged the SumFinder function. It takes 3 parameters, left, right, and array. So it finds the size, finds the mid value, assigns 3 left sum, right sum, and mid sum values, and it finds the sum of the left and right side arrays. And at this point, I was trying to find the subarray sum that crosses the mid value. Okay, so I asked for another help. So it said that I'm on the right track on SumFinder. So, and here what I did was I actually took the merge function, the merge sort operation, and changed it a little bit. How I changed this? So in the SumFinder function, as I did before, I calculated the left sum and the right sum. This is okay. And for the mid sum, I used the while loop I used in the merge operation in the previous example in the medium level. So it finds the array and it merges the array. And for the num in array, mid sum is actually does the num sum. So it sums the num to the mid sum. So what I was trying to do, when we merge two subarrays into one array, this for loop finds the sum of that array. And then I introduced a maximum value here, maximum variable here, and it tries to find the maximum value with the max function here and returns the maximum. But this function was not working properly. So here I rearranged it again. I did this, I added this while loop here. Why? Because it was considering the whole loop. So it's not what I want, because I want to find the sums of the subarrays. But when I tried this code here, it was giving me the sum of the whole array. So in order to avoid this, I wrote this while loop here. Whenever this array is smaller than left size times 2, which is the size of the array is not in size of the whole array, it calculates the mid, otherwise it's not. So I tried to avoid this, but it couldn't work here. So it was wanted me to focus on the mid sum value here. So, and then I changed my perspective totally, and instead of SumFinder function, which is trying to find the subarray sums, I wrote another function. So this function actually assigns the left sum variable here and assigns to the float minus m, which is infinity. it assigns it to the infinity value, and there's a sum equals 0, and in this for loop here it iterates through the left array. Actually, we are trying to find the array in the left side of the mid value, as you can see, and the right sum is actually assigning to the infinity value, and the sum is actually again 0 here. And for I in range, mid 1, height 1, and it calculates the subarray sum in the right side of the mid. So this function includes the mid value, and one of them goes to the left of the mid value, and the other one goes to the right of the mid value. And at the end, we are summing these two and return it. So what we did actually here, we started from the mid value, and before I was starting from the value in the left side, the left side, and go to the right. I was not considering the value at the middle, but in this part we are starting from the mid value and go to the left and go to the right. Okay, so, and right track said I'm on the right track, and here I found the total solution. I checked this out in the IDE. I'm gonna show it on the IDE. So if size of the array is 1, returns the element, and left sum recalls itself, and right sum recalls itself again, and the mid sum calls the max crossing subarray sum. So I didn't change actually the left sum and the right sum part. It works like the approach I did before, but the mid sum works differently with this max crossing subarray sum. And then I returned the maximum number between these three numbers. So I asked for a debug my solution. So it was working. My solution was working. So I calculated the time complexity as O(n) times log n. Since it's a divide and conquer approach again, we are dividing the elements into 2, so the input size grows logarithmically in the power of 2, as we did usually in the previous questions. So I calculated it correctly. So let's see how does these functions work on practice. So this is the function where I used on the medium level questions. So let me go on here. So I already created an array which consists of 44, 3, 8, 12, 89, and I call the function. It prints out 4, which is actually the second smallest element in this function. So let's make this 1, and let's see the result here. And it returns the 3, which is again the second smallest element. So let's move on to the basic level question, which is divide and conquer function. And the aim was to find the maximum element in the array. And I created an array here, and let's call this, it's 45, and let's change this value to 67, for example, and it prints out 67, as you can see here. Now let's see how the hard level algorithm work here. Does it work? And we have an array. This array was given from the ChatGPT as an example in the question. And it has -2, 1, -3, 4, -1, 2, 1, -5, and 4. So the result is calling this function on this array, and when I printed out the result, it gave me the correct answer. So this is basically what I have done with my homework.